Everybody's favorite thing is money, so why not do a problem involving money? In particular, a problem involving money and exponential functions. So we have a setup where a $25,000 inheritance is invested at 5% interest, which is compounded quarterly. How long will it take to double? The formula for a problem like this, where you have intermittently compounded interest, looks like so. It's got a lot of letters in there, but each has a job. The first number on the outside of the parentheses is the amount invested. This n that shows up in two places is the number of times per year that the interest is compounded. R is the interest rate. And the last pair of numbers is A and T, and these are the big payoffs. This is the final amount that's present after the certain time expired. So lots of letters, but they all have a job. Normally the way this is used is we're given an interest rate, we're told we have compounded monthly, compounded quarterly, something like that, in which case n is either 12 or 4 for monthly or quarterly. And we want to know either how long does it take for that initial investment to reach a certain amount, or if we're given a certain amount, or if a certain amount of time has gone by, what's the resulting total amount of the investment now? So here in this problem, a $25,000 inheritance, that's the initial amount invested. It's invested at 5% interest. Now we don't put in the number 5. Remember, we put in 0.05. We decimalize the interest rate. It's compounded quarterly, which means 4 times per year. Zoe, the calculus dog, is really excited about this problem. We don't know the time expired. In fact, that's the question. How long will it take? That means we're looking for T. How long will it take for the investment to double? Well, if the initial investment was $25,000 and we want it to double, we are looking for this scenario. So the rate and the compounding period and the initial investment are givens, and then there's this pair of time gone by versus final amount, and you can provide one and ask for the other either way. Of course, to solve for t, that's a little more interesting here because t is the variable and it's up in the exponent, and so we have to dig it out. Well, the first thing we might want to do is divide both sides by 25,000, which will leave us with just a 2, like so. And notice, actually, that it didn't matter ultimately what the initial investment was. We could have just said, we invested some money, P, how long will it take to double, 2P for this amount, and the actual amount of investment cancels away and just leaves you with the doubling factor of 2. So if I wanted to go back and say I've got 5% interest, compounded quarterly, how long does it take money to triple? We could just put a 1 and a 3 and the same scaling would apply. Now, the variable that we're after is buried up in the exponent, so we need to kick the terms out of the exponent and put them down in the same line as everything else, and that is a job for logarithms. When you don't have any other reason to pick a logarithm, you could pick a log base 10 or a natural log, apply it to either side, and then we're going to use the property that the log of something to an exponent allows that exponent to move down in front. So here, let's just go ahead and do log base 10, because it could be that at this point we haven't introduced even the natural log, or you're still not comfortable with it. So let's just do the log base 10 of both sides, and I'm just going to write that as log because that's the default. If you see log with no base, the default is 10. Now I don't even know what this 0.05 over 4 is. I'm not going to worry about it just yet. And so now the reason I've taken the log of both sides is that now I'm able to drop this exponent down in front. This is another example of making something look worse before it starts to look better. And so now I still have my log of 2 on the left side. Now this exponent of 4t can come down in the same line as everything else. Like that. And now I'm going to solve for t, and I'm going to do it in one fell swoop. To isolate the t, I've got to divide both sides by 4, and I have to divide both sides by this logarithm here. Now, this is just a number. It's written as a messy number right now, but who cares? It's just a number. And so I have my log base 2 from the left-hand side, and now I'm going to divide by 4 and by the log of 1 plus 0.05 over 4. And then out comes the calculator. And then you can start punching buttons to see what this is equal to. You may have wanted to punch buttons to get this simplified a little bit sooner, but, you know, didn't need the diversion at the time. So now go crazy. Go find out what the final value of this is. I will do it myself and report back. And poof, through the magic of technology, the final values have just appeared. In that denominator, 1 plus 0.05 over 4 is 1.0125. And then going all button pushy with that entire expression, we come out with 13.95. And so to be a good student, here's how I finish the problem. I make a little bit more space. And remember, this was a question. A very nicely articulated question was posed. It deserves a proper answer. The proper answer isn't just 13.95 with a squiggle under it. The proper answer is it will take 13.95 years for the investment to double. You can hit pause if you don't want to wait for me to finish writing this stuff. But, ta-da, when we have a nicely posed question, we should have a nicely posed answer to wrap things up, not just a number with a squiggle under it.